Above the blazing factories of the American heartland, a monstrous new bomber rises from impossible blueprints. Thousands of engineers sweat over a machine so ambitious it defies physics, logic, and even hope. Yet, this plane that shouldn't exist will soon rewrite the rules of warfare and cost countless lives to fly. The year was 1940, and the world teetered on the brink. Across Europe, the Luftwaffe's bombers rained fire over cities from Warsaw to London, their precision and range revealing a grim truth. Air power had become decisive in modern warfare. On the other side of the globe, the United States was still a nation at peace, but the whispers of war grew louder, carried on the pages of newspapers and the warnings of military strategists. The Army Air Forces faced a daunting challenge: how to project power across the vast Pacific, to strike Japan if conflict ever erupted. Conventional bombers could barely reach the nearest Japanese-held islands. A new weapon, capable of flying farther, faster, and heavier than anything yet built, was urgently needed. At Boeing's sprawling plant in Seattle, engineers huddled over blueprints that defied contemporary understanding. Tall, wiry men with smudged foreheads and chalk-stained hands sketched wings longer than city buses and fuselages designed to carry unprecedented bomb loads. Among them was a cadre of visionaries who had already flirted with the limits of aeronautical engineering, now tasked with pushing them into the impossible. They spoke in technical shorthand, debating airfoil curves, fuel ratios, and engine placement, each argument layered with the weight of lives that could one day hang on their calculations. Press releases called it the bomber that will change war forever. But the industry knew the truth. It was as much a gamble as a design. Political pressure was relentless. Congress demanded a weapon that could counter Japan without the U.S. needing bases scattered across hostile territories. Military brass fretted over logistics: how to maintain a plane whose wingspan dwarfed hangars, whose engines strained the limits of metallurgy, whose flight characteristics were untested. Yet, amid skepticism, a quiet excitement pulsed through the Boeing plant. Every rivet driven, every mock-up built, was a step closer to turning blueprint into reality. The first prototype, gleaming in raw aluminum and wire-braced wings, rolled out onto the tarmac like a mechanical colossus. Pilots stared, awestruck, at its sheer scale, the fuselage stretching over 70 feet, the engines humming with a potential they had only dreamed of. Test crews circled it warily, aware that this aircraft was not just a machine, but a statement. That America would meet the Axis not merely with courage, but with audacity and innovation. Yet even as cameras snapped photographs for newspapers and press conferences buzzed with excitement, the shadows of the challenges ahead loomed large. Each bolt, each engine, each aerodynamic flaw would soon be a trial of human endurance as much as mechanical ingenuity. The bomber's first tentative taxi across the runway was a spectacle of anticipation and anxiety. For the engineers who had labored through sleepless nights, it was a moment of vindication. For the Army Air Forces, a glimmer of hope. For the world, an omen of the colossal battles yet to come. Dreams had been forged in steel, and yet, for all its promise, the aircraft was only the beginning. Ahead lay long flights over uncharted distances, perilous testing, and the burden of carrying a nation's ambition into war. This was not merely a plane. It was a challenge to the very limits of human invention, and the men who dared to build it knew that failure would be catastrophic. And so, the prototype rested on the tarmac, wings outstretched, engines ready. A symbol of hope, a testament to ambition, and a harbinger of the extraordinary human and mechanical trials that lay ahead. By 1941, the B-29 project had moved from ambitious sketches to the unforgiving reality of engineering a machine that seemed almost impossibly advanced. At Boeing's Wichita plant, the air was thick with the smell of oil, hot metal, and anxious anticipation. This was not just a bomber, it was a blueprint of madness, a technological gauntlet that would push materials, men, and machines to their limits. The bomber's scale alone defied comprehension. A wingspan longer than a city street, a fuselage designed to carry over 20,000 pounds of bombs, and engines, the largest radial engines ever attempted, whose throbbing power demanded perfection from every bolt, bearing, and fuel line. The cabin was pressurized, a first for a U.S. bomber, allowing crews to operate at unprecedented altitudes above 30,000 feet. Engineers wrestled with the intricacies of maintaining pressure without sacrificing structural integrity. Remote-controlled gun turrets, operated from within the cabin through complex mechanical linkages and sighting systems, added another layer of innovation and risk. Every new feature introduced a new variable, and every variable was a potential catastrophe. Tensions ran high. Boeing's lead designers, including the brilliant yet meticulous Edward Curtis, argued tirelessly with U.S. Army project managers over compromises. Weight had to be balanced against armor, fuel capacity against range, defensive armament against speed. Test pilots, recruited from the ranks of the experienced Army Air Forces, were called in early, facing aircraft that could stall, vibrate, or overheat with little warning. In these initial trials, engines frequently ran too hot, straining pistons and bearings to their breaking point. Aluminum skin panels buckled under pressurization, and landing gear collapsed under the bomber's immense weight. Each day brought new setbacks, each prototype flight a calculated gamble between progress and disaster. On the tarmac, the scene was one of relentless scrutiny. Mechanics hunched over engines, swapping parts while monitoring temperature gauges that often registered critical warnings. Engineers scribbled calculations on chalkboards, measuring tolerances down to fractions of an inch. Even minor errors could be fatal. A single miscalculation could tear wings apart at 20,000 feet or send a full bomb load crashing to the ground. Yet amid the chaos, determination burned brighter. Every failure was meticulously logged, analyzed, and corrected. A relentless march toward perfection that consumed months of effort and millions of dollars in resources. And the stakes could not have been higher. The U.S. Army Air Forces watched from offices thousands of miles away, aware that the bomber's success would redefine air warfare. If the B-29 performed as envisioned, it would strike deep into enemy territory, bypassing the need for distant bases and delivering a payload unimaginable in size and precision. If it failed, the cost would be measured not only in shattered aircraft but in human lives and national credibility. By the end of these early trials, a sobering realization had taken hold. The B-29 was more than a bomber. It was an experiment in human endurance and mechanical ambition. Every rivet, every engine test, every cabin pressure adjustment was a step into uncharted territory. The bomber's promise hung in the balance, a knife edge between innovation that could tilt the war in America's favor and failure that could bury it under a mountain of smoke, fire, and lost lives. The aircraft rested on the runway once more, its engines ticking as they cooled in the evening light. It gleamed with potential, yet whispered of the immense trials still ahead. Success would change the face of aerial warfare forever. Failure would be catastrophic. The blueprint of madness had become a tangible, humming leviathan, and the world waited to see if it could be tamed. The roar of the factories was deafening. At Boeing's sprawling plants in Wichita, Renton, and Seattle, the world of aviation had become a furnace of steel, sweat, and urgency. Thousands of workers moved with relentless purpose, assembling engines, fuselages, wings, and control systems that would make the B-29 a machine unlike any ever built. The smell of molten metal mingled with oil and scorched paint, while sparks leapt from welding torches like fleeting stars in a storm of labor. Every station, every bolt, every rivet carried the weight of lives to come. The stakes pressed into the skin of those who labored hour after hour under impossible deadlines. The war had reshaped the workforce. Women, long relegated to clerical work, now ran presses, riveted wings, and calibrated instruments with precision that rivaled the most seasoned male machinists. African-American men and women found opportunities, yet faced discrimination and segregation, their contributions critical yet too often marginalized in reports and photographs. Immigrants, veterans of the Depression, and teenagers fresh from high school filled gaps left by men deployed overseas, all under the shadow of constant urgency. Each shift was a race against the clock, a battle against the limitations of human endurance as much as the complexities of the machine. The pressure was relentless. Government inspectors prowled the assembly lines, checking tolerances to thousandths of an inch, testing engines that frequently overheated during trials, and verifying every component of the pressurized cabin and remote-controlled turrets. Any flaw could doom a test flight or worse, a combat mission. Sabotage was a real fear. Whispers of spies or careless errors fed the anxiety that this massive, delicate endeavor could be undone by a single moment of negligence. Exhaustion was omnipresent. Workers slept in shifts, sometimes forgoing meals, while the constant vibration of machinery throbbed through the bones. Steel plates were hoisted overhead, engines lowered into mounts with a precision that demanded full concentration. The human toll was real. Sprains, burns, and accidents peppered the floors, yet the work continued, driven by patriotism, fear, and the sheer understanding that failure here would echo thousands of miles across the Pacific. Amid this crucible, small victories were celebrated quietly. A wing assembly finished a day ahead of schedule, a fuel pump calibrated without error, a turret successfully wired for remote operation. These were the sparks of hope in a world dominated by tension. Yet the bomber remained fragile. Early production B-29s rolled off the line still incomplete, unfinished in ways that made test pilots wary and engineers anxious. Every plane shipped to training or testing grounds was a potential masterpiece or a harbinger of disaster, its gleaming skin hiding the stresses and compromises forced by human limitations. As the first production models were loaded onto transport trucks and trains bound for airfields in Kansas and New Mexico, the enormity of the project crystallized. Thousands of hands had shaped them, countless hours logged, millions of dollars invested, all converging on machines still vulnerable to failure. The factories had done their work, but the true test, the skies, the engineers' calculations meeting the unforgiving laws of physics, and ultimately the crucible of war, still lay ahead. The fires of the factory had forged the B-29, but it was only the beginning. Triumph and catastrophe teetered on the edge of every rivet, every bolt, and every turn of the propeller. The first B-29 lifted off into the gray Kansas sky in September 1943, a gleaming leviathan stretching its massive wings against the horizon. Beneath the roar of the four Wright R-3350 duplex Cyclone engines, a small crew held their breath, acutely aware that every rivet, every cable, every new system they had learned to operate in simulators was about to be tested against the unforgiving air above. From the control tower, engineers and Army officers tracked the bomber's every motion, their eyes scanning for tremors in the wings, smoke from the engines, any sign that the machine might betray them. Chaos arrived quickly. Within minutes, engines overheated, their radial cylinders glowing red from friction and poor cooling airflow. One aircraft was forced to abort, limping back to the runway with smoke trailing from a nacelle. Another, only halfway through a test pattern, suffered a hydraulic failure that left the landing gear locked partially down, forcing a harrowing emergency landing. Pilots recorded every moment in radio logs, their voices taut with tension. Number 2 engine, flames in the cowling, were feathering it, attempting climb on 3 and 4. Diaries later revealed their dual feelings of exhilaration and dread, marveling at the aircraft's potential while acutely aware of how close each flight brought them to catastrophe. The innovations that made the B-29 revolutionary also made it unforgiving. Pressurized cabins required constant monitoring, with oxygen systems needing delicate adjustment. Remote-controlled turrets demanded precision, coordination, and nerves of steel. The immense weight of fuel, bombs, and engines meant that any miscalculation in speed or angle could tip the bomber into a fatal stall. Early missions often ended with engines failing, fire suppression systems misfiring, or structural panels loosening in mid-flight. Each setback was a harsh lesson in the limits of contemporary engineering and the human capacity to adapt under pressure. Training evolved rapidly. Crews who had once learned to operate bombers with manual guns and simple instrumentation now faced systems that demanded new protocols and split-second decisions. Flight instructors pored over data from every sortie, noting which maneuvers stressed the airframe, which engine settings led to overheating, and how best to coordinate between gunners, pilots, and flight engineers. These trials were brutal, often punishing in both mechanical and human terms, but they gradually forged procedures that would become the backbone of operational missions over the Pacific. Yet for all the lessons learned, the irony was bitter. The B-29's promise was boundless. A bomber that could reach Tokyo from distant Pacific bases, carrying payloads the world had never seen. But its reality was terrifying. A machine capable of extraordinary achievement, yet just as capable of killing its own crew before it even reached the target. Every flight was a gamble, every landing a triumph against the odds. Engineers patched engines, modified turrets, and reinforced structures. But the sky remained an arena of uncertainty, where the difference between success and disaster was measured in seconds. As the sun set over the training fields, a lone B-29 glided back from its latest test, wings trembling, engines smoking lightly, but intact. It carried within it both hope and menace, the embodiment of human ingenuity and the stark reminder that even the most advanced technology could be lethal. The skies had been conquered only partially. The bomber's true test still lay ahead in the crucible of war. Its destiny, like the men who dared to fly it, hung in the balance. By late 1944, the B-29 had moved from testing grounds to the crucible of war, tasked with a mission that seemed almost impossible. Strike the Japanese homeland from thousands of miles away, flying at altitudes that pushed both machine and crew to their limits. The logistical nightmare began immediately. The China-Burma-India theater was a web of inhospitable terrain, precarious supply lines, and aircraft ferried over the treacherous Himalayan hump. Every gallon of fuel, every spare engine part, every bomb had to traverse this hostile expanse before a single sortie could reach Japan. Airfields in China were carved from hillsides, often under construction even as the first B-29s landed, leaving crews to navigate dirt runways under monsoon rains and constant threat of enemy attack. Crews faced the full spectrum of trial by fire before ever reaching Japanese airspace. Pilots struggled with engines prone to overheating on the long climbs over the Himalayas. Oxygen systems failed sporadically at 30,000 feet, leaving men to operate half-conscious in thin, freezing air. Flight engineers, relying on gauges still untested in combat, adjusted fuel mixtures and engine temperatures on the fly, knowing a single miscalculation could trigger a catastrophic fire. For many, the first missions were as much a test of human endurance as mechanical capability. Radio logs and diaries reveal a mixture of awe and terror. "We climb, and the world falls away beneath us," one engineer wrote. "But I pray the engines hold until we turn for home." Losses were inevitable. Some bombers never returned from the hump, their engines failing over inhospitable mountains, their crews trapped by altitude and weather. Others made it to staging areas in China only to face further delays, as supplies arrived late or fuel convoys were attacked by Japanese forces. Yet amid the struggle, small victories bolstered morale. Successful missions delivered payloads to strategic targets, and the lessons learned in every aborted flight, every engine failure, and every near-miss forged procedures that would save lives in future operations. Crews adapted, refining navigation over hostile terrain, optimizing engine use and coordinating defensive fire, transforming the B-29 from a fragile marvel into a weapon capable of sustained strategic bombing. The moral weight of these missions was profound. Pilots risked their lives flying experimental technology, knowing that a single mechanical failure could be fatal. Engineers tracked performance data from afar, witnessing flames lick fuselages during flights that tested both human and machine. Military leaders weighed every sortie against political necessity and strategic opportunity, balancing the potential of the aircraft against the certainty of risk. Every mission was a negotiation between ambition and survival, between the promise of a new weapon and the cost in human life. When the first combat missions reached Japan, the B-29 proved both miraculous and deadly. It soared above flak, evaded interceptors at unprecedented altitudes, and delivered bomb loads far heavier than any conventional aircraft could carry. But every mission also revealed the bomber's fragility. Engines overheated, fuel pumps failed, and defensive systems sometimes jammed. Yet, even in imperfection, the B-29 demonstrated its revolutionary potential, hinting at the decisive role it would play in bringing the Pacific War to an end. By the time crews returned from their first raids, they had glimpsed the paradox at the heart of the B-29, a machine that was both a marvel of human ingenuity and a crucible of human courage. It was a war within a war, fought in skies where altitude, distance, and technology collided, and where every flight was a test of endurance, skill, and resolve. The B-29 had arrived in battle, untamed, deadly, and poised to change the course of the conflict. As 1945 dawned over the Pacific, the B-29s of the 20th Air Force carved silhouettes against the pale horizon, climbing to altitudes of 30,000 feet and beyond. From these heights, the Japanese archipelago lay beneath them, a sprawling maze of cities, factories, and transport networks. The sky was cold, the thin air biting at exposed skin and pressurized cabins humming with mechanical life. Engines roared, propellers slicing through clouds, each radial cylinder vibrating with a fury that mirrored the tension in the crew's chests. Over Tokyo, the first raids began in earnest. Anti-aircraft fire stitched the sky with flak bursts, black puffs that blossomed around the bombers, each one a deadly potential. Interceptor aircraft occasionally appeared, their silhouettes small yet menacing, as gunners on the B-29s trained their remote-controlled turrets on the approaching threat. Inside, pilots adjusted headings, engineers monitored temperatures, and bombardiers lined up targets with painstaking precision, aware that even a minor miscalculation could send a bomber spiraling into catastrophe. The incendiary raids revealed both the aircraft's unprecedented power and its fragility. Bombs designed to ignite entire districts tore through wooden neighborhoods, flames leaping skyward, smoke twisting into clouds that mirrored the turbulence above. But within the bomber, frostbite nipped fingers, cockpit windows fogged with condensation, and engines threatened to overheat under prolonged strain. Crew members wrote later of engines flaming mid-flight, of warning lights screaming in unison, of moments when survival seemed as uncertain as mission success. Yet even amid exhaustion and fear, there was a grim recognition of effectiveness. The B-29 could deliver destruction on a scale previously unimagined, striking at industrial heartlands and crippling supply networks, altering the calculus of war from the air. But with each city reduced to fire and ash came a profound human weight. Pilots and gunners carried the paradox of power, the pride of achieving an objective, tempered by the knowledge of the lives and homes destroyed below. Diaries and post-mission logs speak of silence after a raid, a reflective stillness that often lasted long after engines had cooled. Men haunted by what their machines had wrought. The B-29's temperamental nature persisted even in success. Repairs were constant. Ground crews labored night and day to keep engines serviceable, hydraulics responsive, and turrets operational. Every mission was a delicate negotiation with physics, endurance, and risk. Flying these bombers became a test not only of skill and courage but of the crew's ability to survive the very machine they commanded. Above the smoldering cities, the B-29 remained both marvel and menace, a vehicle of human ingenuity and destruction. Its legacy was written in fire and smoke, in engineering triumph and human cost, a testament to the heights of wartime ambition and the depths of wartime consequence. By August 1945, the B-29 had transcended its role as a conventional bomber, becoming the linchpin of an operation that would alter the course of history. From the island of Tinian in the Mariana Archipelago, specially modified B-29s prepared for missions unlike any before, long-range flights carrying the first atomic bombs, instruments of destruction as unprecedented as the aircraft that delivered them. Every aspect of these missions demanded technological ingenuity. Pressurized cabins that shielded crews from the thin, freezing air at 30,000 feet, advanced navigation systems to ensure precision over thousands of miles, and electronic fire control systems guiding defensive turrets with unprecedented accuracy. The bomber's long developmental journey had forged these milestones, often at tremendous human cost. Engineers labored endlessly to tame engines prone to overheating, to perfect fuel systems capable of sustained flight, to calibrate pressurization and electronics that could fail under the smallest deviation. Pilots and flight crews endured grueling training, delicate balance of speed, altitude, and payload while confronting the ever-present threat of mechanical failure. In factories, thousands of hands riveted fuselages and assembled complex systems, often working double shifts under wartime pressure, their labor shaping a machine that would define the final act of a global conflict. When the first missions lifted, the B-29 proved its capabilities and its paradox. It flew farther than any bomber before, carried loads unimaginable in weight and destructive potential, and delivered ordnance with precision that conventional aircraft could not match. Yet the plane remained temperamental, a fragile leviathan that demanded absolute vigilance. Pilots and crews faced the dual realities of awe and terror. A machine that embodied human ingenuity but wielded the power to obliterate cities, leaving them to confront the moral and psychological weight of their role. In Hiroshima and Nagasaki, the consequences of that ingenuity were made painfully clear. Cities flattened, tens of thousands killed instantly, and countless more affected in the months and years that followed. The B-29, once a symbol of audacious engineering, had become the instrument of decisions that would haunt survivors, crews, and nations alike. It was a triumph over technological limits, a testament to human perseverance and ambition, yet it carried with it a shadow that no innovation could dispel. The legacy of the B-29 is inseparable from this duality. It reshaped air warfare forever, proving that a machine once thought impossible could dominate the skies, traverse vast distances, and alter strategic calculations across the globe. Yet its triumph was inseparable from the human cost it exacted, the pilots who risked their lives, the engineers who labored beyond exhaustion, the civilians caught in its shadow. In its wings, the promise of innovation and the weight of moral complexity flew together, leaving a mark on history as enduring and conflicted as the war itself. The B-29 had achieved what once seemed impossible. From its first tentative roll onto the tarmac to its devastating missions over Japan, it defied expectations at every turn, a testament to audacious engineering and human perseverance. Wings stretching over 140 feet, engines churning with unparalleled power, cabins pressurized for comfort and survival at extreme altitude. This was a machine that had transformed air warfare, yet one that carried the weight of its own contradictions. It was a symbol of duality. Every technological triumph, the remote-controlled turrets, advanced navigation systems, and long-range capabilities, was mirrored by human vulnerability. Pilots faced engines prone to spontaneous fires, frostbite at 30,000 feet, and the constant threat of mechanical failure. Engineers worked through exhaustion and anxiety, knowing that every miscalculation could mean disaster. Factory floors burned with molten metal and sweat, as thousands of workers labored under pressure, shaping components that were as delicate as they were massive. In the B-29, ambition and mortality coexisted, fused into a flying paradox. The war may have ended, but the B-29's influence endured. Its innovations reshaped post-war aircraft design, laying the groundwork for jet propulsion, pressurized cabins, and strategic bombing doctrines that would dominate the Cold War. Airfields around the world were constructed to accommodate its size and range, and strategic planners recalibrated their concepts of what air power could achieve. The lessons of its fragility, temperamental engines, and the meticulous care it demanded informed decades of aeronautical engineering. Yet even as it left a mark on global strategy and technology, the moral weight of the B-29 remained. It had delivered unprecedented destructive power, claimed thousands of lives, and reshaped the human and urban landscape of Japan. Pilots, crews, and engineers carried with them memories of fear, triumph, and lingering unease, an acknowledgement that the plane's genius was inseparable from the cost it imposed. Archival footage fades in the mind's eye. B-29 silhouetted against sunrises over the Pacific, engines screaming, wings trembling with lift. They rise and disappear into clouds, leaving behind a history written in both steel and fire. A machine born of daring innovation, forged through human endurance, and tested in the crucible of war. It was, and remains, the plane that shouldn't exist, a monument to the extraordinary heights and devastating shadows of human ambition. The B-29 left the skies of war behind, yet its story endures. A testament to ingenuity, a warning of power, and a reminder that the line between brilliance and danger is often as thin as a rivet in the wing of a bomber that defied all odds.